Hi guys, so today we're going to look at graphing rational functions that are more than just a simple transformation of the parent function. So in order to graph rational functions, there's really four pieces that we need to define. The first is the vertical asymptote, the second is the horizontal asymptote, then we look for our x-intercepts and our y-intercept. So from here, we're going to start with the vertical asymptote. So we already talked about this a little bit when we did transformations. The reason we get a vertical asymptote is because you can't divide by 0. So if you get a number divided by 0, it's undefined. And that's where we're going to have a vertical asymptote. So the way we find them on our function is we set the bottom equal to 0. Horizontal asymptotes are a little bit different. Now, there's not really a lot of math required here, but there are some rules that you do need to know. So horizontal asymptotes will show the end behavior of the graph. So what we do is we look at the degree of the top of the function and the degree at the bottom of the function. Remember, degree, when we did polynomials, that was the biggest exponent when it was written in standard form. So if it's a bottom-heavy degree, so what we mean by that is the degree on the bottom is bigger than the degree on the top, then our horizontal asymptote is just y equals 0. If they're the same degree, top and bottom, then we divide our leading coefficients. And remember, the leading coefficient is the coefficient of that highest exponent term. So this would look like y equals leading coefficient over leading coefficient. If it's top-heavy, so the degree on the top is higher, there is not going to be a horizontal asymptote. But you will have, more than likely, a slant asymptote. And that's what we're going to get into next class. All right, so the next two things we find are our intercepts. So x-intercepts, just like they have been for every function we've done so far. Our x-intercepts for polynomials, we solved, we found the roots, we found when the equation equaled 0. Same thing for quadratics, we found when the quadratic equaled 0. Well, our x-intercepts for a rational function, same thing, we want the function to equal 0. But what's nice about a rational function, it doesn't matter about the whole function. 0 divided by anything is going to give me 0. So to find the x-intercepts, all I have to do is set the top equal to 0. Then y-intercepts, we're going to do those the exact same way we have done every y-intercept we've ever done. And that is we plug, a little messy, we plug in 0 for every x. Okay, for every x we plug in 0. Now the last part, we looked at this in class when we looked at a lot of different examples of what these graphs look like. And two kind of special features on our graph happen whenever we had squared factors. So whenever you have a squared factor, it's going to kind of do something a little bit different. So the first one we talked about was if we had a squared factor in the top. Okay, so a squared factor at the top. So that would mean that the x-intercept had a squared factor. We said this was just like it was for polynomials. So whenever we talked about multiplicity for polynomials, if we had a graph that looks like this graph would cross at -3, it would touch or bounce at 3, and touch or bounce at -7 because it had that even exponent. Well, it's going to be the same idea for rational functions. If the top has a squared factor, if that x-intercept has a squared factor, your graph is going to touch or bounce at that x-intercept. And again, it's specifically the x-intercept that has the squared factor, just like it was for polynomials. Now, if there's a squared factor in the bottom, okay, this is going to affect our vertical asymptotes. So when we looked at all those examples in class, and if you think about all the parent functions we looked at the first day, typically at an asymptote, if one side was up, the other side was down. And it could have been either way. If this side was going up at the asymptote, this side was going down at the asymptote. And that's going to be the case for a lot of the times. When it's not going to be the case, and when your graph is going to go in the same direction at that asymptote, is when you get that squared factor in the denominator. So if there's a squared factor in the bottom, okay, then your graph is going to go in the same direction on both sides of the vertical asymptote. And again, it's at the asymptote that has that squared factor. So if you can't remember some of those examples we did in class, the link for the Desmos activity has all those examples as well, and you can kind of go back through those and see what it does to your graphs. All right, so let's just start by finding horizontal asymptotes, because that's kind of the new one with our new rules. So horizontal asymptote, we look at the degree of the top and the degree of the bottom. Well, on this first one, that's a degree 4, and the bottom's a degree 4, which means this is the same degree. If it's the same degree, I divide my leading coefficients. So my horizontal asymptote is y equals 4. All right, looking at the next one. That's a first and a first, so that would overall be a second degree. I've got squared and first, so that would be third degree. That means that this one has a higher degree on the bottom, so it's bottom heavy, so it's y equals 0. Then on the last one, biggest exponent on top and bottom, this one is top heavy. That means there is no horizontal asymptote. When we get to our next lesson, we're going to look at how to find the slant asymptote for this function. All right, so we're going to start just by finding all the pieces that we just talked about. Now, the most important thing when it comes to these functions is that you have to factor the top and the bottom first. And this will be really important, especially next class when we start looking for holes. But we always factor top and bottom. So what I'm going to do is I'm going to start by taking out my GCF. Then, after I take out that GCF, that's going to leave me with, and let me go ahead and just erase this for some space. That would be 2, x plus 3, x minus 3. All right, then we're going to factor the bottom. So a is greater than 1, so we have to go through that longer process. So think about what multiplies to a negative 24 and adds to 5. And that's going to be positive 8 and negative 3. So I'm going to rewrite the middle into those two terms. And then I'm going to do grouping. Out of those first two terms, 2x comes out, left with x minus 4. Out of the next two terms, minus 3 comes out, left with x minus 4. And I don't know why I put minus. These should both be pluses. Sorry about that. So my matching factor, okay, I'll go ahead and write it under here. The matching factor was x plus 4. The other factor was 2x minus 3. So now I've factored that equation. All right, once my equation's factored, I'm going to use that factored form to answer all of those things we just talked about. So we'll start with the vertical asymptotes. So if you look back on your notes, the way we find the vertical asymptote, we set the bottom equal to 0. So I set each factor equal to 0. So if I do x plus 4 equals 0, I get x equals negative 4. And that's my first vertical asymptote. My second vertical asymptote, set that equal to 0, I would get x equals 3 over 2. Horizontal asymptotes, again, this is a little bit easier if you look at the original function, not the factored function. So we look at the top and the bottom degree. Those were both second degree. So if it's the same degree, we divide the leading coefficients. So 2 divided by 2 gives me a horizontal asymptote of y equals 1. Now, it's really important when you write this. We always write vertical asymptotes and horizontal asymptotes as lines. So vertical asymptotes are always x equals, horizontal asymptotes are always y equals. All right, then let's move on to our intercepts. So x-intercepts, we set the top equal to 0. So if I do x plus 3 equals 0, I get x equals negative 3. And we have to write these as coordinates. So it's negative 3, comma 0. Same thing, x minus 3, that would become 3, comma 0. All right, and then our last one, we'll go ahead and do our y-intercept. This one's also a little bit easier to use the original function for, because then I don't have to worry about multiplying or anything like that. So I'm just going to plug in 0 for all my x's. Well, 2 times 0 minus 18 is negative 18. 0 plus 0 minus 12 is a negative 12. So that would reduce to 3 over 2. And again, we write this as a coordinate, so it's 0, comma 3 over 2. And then here in a little bit, we're going to actually put this on the graph. But for now, we're just going to focus on finding all these components. All right, so let's go ahead and go on to our next one. So the first thing we need to do is factor. So to factor, we're going to do grouping here. 9x squared comes out, left with x minus 3. Minus 4 comes out, left with x minus 3. So 9x squared minus 4 and x minus 3. But this actually factors more. 9x squared minus 4 factors into 3x plus 2 and 3x minus 2. All right, so then from this point, we're going to use this factored form or the original, depending on which one's easier, to find all these pieces. So we're going to start with the vertical asymptote, setting each factor of the bottom equal to 0. So I get x equals negative 2/3. Then I get x equals 2/3. And then finally I get x equals 3. So this graph has 3 vertical asymptotes. Horizontal asymptote, degree of the top, degree of the bottom. Well, that's a 0 degree and a 3rd degree, so this is definitely bottom heavy, so it's y equals 0. For x-intercepts, we set the top equal to 0. Well, 7 is never going to equal 0, so this graph actually has no x-intercepts. Then to get our y-intercepts, I plug in 0 for every x, so plug in 0, 0, and 0, and I'm left with 7 over 12. All right, then going on to our last one. Again, probably the hardest thing on some of these is just the factoring. So to factor the top, I'm going to start by taking out my GCF, which is 2x. That leaves me with a difference of cubes. So to factor that difference of cubes, I start with the cube root of both terms. Then I'm going to follow my SCUMS acronym. Square the first, change the sign, multiply, square the last. So that is how the top factors. To factor the bottom, I need to go through and multiply my a times c and split up my middle. So what multiplies to a negative 70 and adds to a negative 3? So that's going to be a negative 10 and a positive 7. So I'm going to rewrite this, and even though it's to the 4th, that's okay. I just keep those variables the same while I work this out. So minus 10x squared plus 7x squared minus 35. Do my grouping. So I end up with 2x squared plus 7 and x squared minus 5. So I want to kind of just rewrite this so you guys can see the full factored form. So this is 2x. Scoot down a little bit. So my final factored form here is 2x times x minus 2 times x squared plus 2x plus 4. The bottom fully factored was 2x squared plus 7 and x squared minus 5. So now we're going to go through and find all those pieces that we just talked about. All right, so vertical asymptotes, the first thing. Set the bottom equal to 0. Well, it's a little bit harder this time, okay? So I'm going to go ahead and erase that factoring work so we can show a little bit of work for setting the bottom equal to 0. If I do 2x squared plus 7 equals 0, I get that x squared is equal to negative 7 over 2. Well, I can't take the square root of a negative number, so this is not going to give me any vertical asymptotes. All right, let's do x squared minus 5 equals 0. And I get that x equals plus or minus the square root of 5. So I have 2 vertical asymptotes. All right, then we're going to go to horizontal asymptotes. So we'll look at the degree of the top and the degree of the bottom. So this was the same degree. So I would divide those leading coefficients. And I get y equals 1. All right, x-intercepts, set the top equal to 0. Now, this was supposed to be squared. If I set this factor equal to 0, I'm not going to get any real answers. If you remember, whenever we solve polynomials, those always end up imaginary. So I'm only going to get x-intercepts from these 2 factors. So one of those would be 2. The other would be 0. Then the last thing I would need is y-intercept. Plug in 0 for all of those x's, and I end up with 0 divided by negative 35. 0 divided by anything is 0. That also makes sense because if 0, 0 is an x-intercept, then 0, 0 is also your y-intercept. All right, so we're going to follow this same pattern for finding all of these components for every single problem we do. Some of them will have a couple extra steps, and we're also going to sketch the graph. But for now, we're just finding these individual components. All right, so let's go ahead and actually graph this. So we're going to start, again, the same way we just did. Vertical asymptote, set the bottom equal to 0. So I'm going to graph the line x equals 1. It's an asymptote, so I'm going to make it a dotted line. Horizontal asymptote, degree of the top and degree of the bottom. Same degree, divide the leading coefficients. X-intercept, set the top equal to 0. So that gives me 3 over 2, comma 0. So that's about 1.5. Then we've got the y-intercept. So plug in 0 for all of my x's, and that gives me 3 for the y-coordinate. So now I need to sketch my graph. And this is the part where a lot of people have trouble or get kind of worried about it. Now, if you have found all of these features so far, you've done a really good job, okay? This last part's probably the hardest part, but we're going to take it step by step. So the first thing we need to consider, our graph is going to go towards our asymptotes, all right? So we just need to figure out, really, am I going to sketch a graph in this box or this box? I can't do it in both, because if I draw it in both, I don't have a function. Well, I'm going to choose to draw this graph in the top left box because there's already a point in the top left box. So then all I have to do is go through that point and make my ends going towards my asymptote. I don't need to really get more accurate than that. Okay, then we look at the next side. Now we got a couple of clues here. We talked about how that asymptote, if that factor wasn't squared, I'm going to go in opposite directions on both sides. That also makes sense because I have a point here that I need to go through. So I'm going to go through that point, and I kind of touch those asymptotes. I'm going to go through that point and go towards my asymptotes. And then I have my graph. All right, let's look at another one. Again, first step is always factor. So top and bottom, that's x minus 3 times x minus 3. Or we could write that as x minus 3 squared. Well, that means I have a vertical asymptote at x equals 3, and it's squared. I'm going to make a note of that because, again, that's going to have an effect on our graph. All right, horizontal asymptote. Top heavy, bottom heavy. We look at this, it's bottom heavy. So it's y equals 0. And then we graph our x-intercept. I set the top equal to 0. Well, the top's not going to equal 0, so there are no x-intercepts. Y-intercept, plug in 0 for all your x's, and I get 1/9. All right, so I'm going to start with my first curve. Well, I'm probably going to draw it in this top box because there's already a point in that box. So we're going to go ahead and draw one of our curves in that top box. Now, I need to figure out, am I going to be in this box or this box? Well, this was a squared factor. And if we have a squared factor at that asymptote, your graph is going to go in the same direction on both sides of that asymptote. So if it was up on the left, it needs to be up on the right, which means this is going to be in the top right box. All right, let's do a couple more. Again, always start by factoring the top and factoring the bottom. That's a difference of squares. So let's start with our vertical asymptotes. So there's 2 this time. X equals -3 and x equals +3. So once we get 2 asymptotes, that's when these graphs start to get a little bit harder to draw. Because as you saw in class, that little middle section can do a lot of different things. It can do one of these, it can do one of these, it can do one of these or one of those. It's got a lot of different options. So we're going to use the information we have about this graph to determine what it's going to do. But let's find our other pieces first. All right, horizontal asymptote, this is bottom heavy. So y equals 0. X-intercept, set the top equal to 0. Doesn't happen. Oops, thinking of a different problem. Does happen. That's 1, 0. And that gives us a pretty good clue right there because now we have a point on the horizontal asymptote. All right, then we're going to go to y-intercept, plug in 0 for my x's, and I get 0, 1/9. So now I'm going to sketch my graph. So let's start from the y-intercept. So from that y-intercept, I'm either going to go up towards this asymptote or down towards that asymptote. I cannot cross that vertical asymptote, so I only have two options. Well, the problem, if I turn and go down, I've now created another x-intercept that doesn't exist. So I can't do that. So from this intercept, I have to go up towards that asymptote. All right, now we're going to look at our x-intercept. So that factor was not squared. If it was squared, we could bounce and go up. But it was not squared, so we have to cross through it. So if I cross through it, I'm going to go down towards this asymptote. Then we can use what we know about our asymptotes. None of those factors were squared. They were all to the first power. So that means at the asymptote, my graph is going to go in opposite directions on both sides. That means I have to have a curve in the bottom left and the top right. Now, what you can also do, if that part doesn't really make sense, is you can pick some test points. And what's nice about this, we don't really need the exact perfect value, because some of these values will be pretty ugly. They'll be fractions and things like that. What we really need to know is, will my graph be positive or negative in that region? So let's pick some number that falls to the left of that asymptote. All right, so let's say a -6. If I plug in a -6 for x to the top, -6 minus 1 is a negative number. If I plug in -6 to this factor, -6 plus 3 is a negative number. If I plug in -6 over here, -6 minus 3 is a negative number. Well, a negative divided by a negative times a negative overall is going to be negative. So that's why this region is below my axis and not above. We can do the same thing in any section of the graph. We could pick a point in this region, we could pick a point in this region, or we could pick a point over here. So let's go ahead and try one on that far right just to double check. So let me get rid of that so you can see the original problem. Okay, so let's start by picking a test point. Let's say 6, +6 this time. Well, 6 minus 1 is a positive number. 6 plus 3 is a positive, and 6 minus 3 is a positive. Positive divided by positive times positive overall is positive. So that's why this graph is above the x-axis in that point. So that's another way you can help to kind of see how your graphs look. All right, we're just going to do the same thing for a couple more. We'll go ahead and factor. When a is 1, remember these are the easy ones to factor. All I need is what multiplies to -12 and adds to -1. And those are my factors. When a is 1, these are short, simple, and easy. Vertical asymptotes, set the bottom equal to 0. So I'm going to go ahead and graph those. All right, horizontal asymptote. This one is bottom heavy. So that horizontal asymptote is y equals 0. X-intercept. Set the top equal to 0. Doesn't happen, so there will be no x-intercepts. Y-intercept, plug in 0 for your x's. I get 0, -5/12, so somewhere over there. So now it's time to sketch my graph. Well, a big clue for this graph, there are no x-intercepts, so I cannot cross the x-axis. So from that red point I just plotted, I cannot go up towards that asymptote because I can't cross the x-axis. So I have to go down on both sides, and it creates one of those little parabolas. Well, again, there were no squared factors, so I have to be going in the opposite direction on both sides of these asymptotes. So I'm in the top left box, and I'm in the top right box. Now again, if you want to pick a test point, pick any test point in that region, plug it in, you'll end up with positive over here, and you'd end up with negative in the middle. So you can use that as well to help you see what your graph is going to look like. All right, let's go ahead and factor. Start with the GCF. And then now I have a is 1, so what multiplies to -8 and adds to -2. Then on the top, multiplies to 1, adds to -2. And that factor in the top is on there twice, which means if we want, we can write that as x minus 1 squared. That means I have a squared factor, so it's going to have kind of one of those little different looks to it. All right, vertical asymptotes. Set the bottom equal to 0. So there are two vertical asymptotes again. Okay, horizontal asymptote. Degree of the top and bottom are the same. Divide those leading coefficients. X-intercept, set the top equal to 0. Well, there's only one place, but it was squared. That means your graph is going to touch or bounce off that point. Then I've got the y-intercept. Plug in 0 for all of my x's. And I get 0, negative 1/4. All right, so then from here, we're going to sketch our graph. So let's start from the y-intercept. I cannot go up towards that asymptote because I cannot cross it. I can't cross it and create a new x-intercept that doesn't exist. So I'm going to have to go down towards this asymptote. Now at this x-intercept, that factor was squared. So I'm not going to cross through it. I'm going to touch it and go back down because that x-intercept had a squared factor. We did not have any squared factors in the denominator though, so at my asymptotes, I should be going in the opposite direction. So there's a curve, and there's a curve. And there's my graph. All right, let's just look at one more. Let's go ahead and factor. Take out the GCF from the bottom. So I've got two vertical asymptotes, x equals 0 and x equals negative 4. Horizontal asymptote, well, let me go ahead and graph those first. Horizontal asymptote, degree of the top, degree of the bottom, bottom heavy. So we'll go ahead and graph that as well. X-intercept, set the top equal to 0, which is on my horizontal asymptote. And then y-intercept, plug in 0 for all of your x's. Well, that gives me negative 3 divided by 0. That is undefined, which means that there is no y-intercept, which makes sense because you have a vertical asymptote there. You can't have a point on the vertical asymptote. So the problem about this, we now only have one point to help us figure out what this graph looks like. And that's not really enough information to see what my graph is going to do. So what I need to do is I need to pick some test points. So I'm going to pick a point in this region just to see if my graph is going to be positive or negative. So let's take negative 8. If I plug in negative 8 minus 3 is a negative number. Negative 8 over there would be a negative, and then negative 8 plus 4 is a negative. Negative divided by negative times negative is negative. So this region is all negative. All right, again, at this point, you can use what you know about your asymptotes, or you can pick another test point. Let's do another test point just for practice. Let's do negative 2. If I plug in negative 2 to the top, negative 2 minus 3 is a negative number. Negative 2 plugged in for x is a negative. Negative 2 plus 4 is a positive. A negative divided by a negative times a positive is going to be positive. So this region is positive. So now my last region, again, I can pick some test points, but I know at this asymptote, the factor wasn't squared. I'm going to have to go in opposite directions, so I know this end's going to be down. Now what's weird here, though, is I am going to cross through this point, but I'm not just going to go up forever. I know this graph is going to go towards my horizontal asymptote. So even though I cross through this point, I'm still going to go down towards that asymptote. Yeah, you don't have to worry about how high that part goes. You just need to make sure that you cross through that x-intercept and keep going towards the horizontal asymptote. All right, so the most important thing out of this to understand is really how to find all of these components. That's really the most important part here. I know sketching the graph can be a little bit overwhelming, but the more of these you do, the easier they're going to get.